Right, good morning and happy Tuesday. I am going to need you all to kind of bear with me as we continue to master isotopes. Quick review: an isotope is just the same element, meaning it has the same number of protons with a different mass, meaning it's going to have a different number of neutrons. Today, for my algebra lovers, I know you're going to love this. My non-algebra lovers, please make sure you're following this video and staying organized so that you can be set up for success when determining the percent abundance. All right, let's jump in. Isotopic percent abundance, what does that even mean? Well, it pretty much means what's the percent of this isotope in nature? How likely am I going to find this isotope? So here I have a graph of chlorine. Let's see how often we're going to see chlorine. So chlorine with a mass of 35 is found about 75.8% in nature, meaning there's a lot of this isotope of chlorine in nature. Chlorine also has another isotope of chlorine 37, meaning it has a couple more neutrons, 2 more. And that isotope is only found about 24% in nature, meaning it's not as common as this isotope. They are both there. However, you're going to find this isotope more than this one. And today we're going to learn exactly how to calculate what is the percent of each isotope that I'm going to find in nature. Which one am I more likely to see? Again, a higher percent, it's going to be more available in nature. A lower percent means it's not as common. So let's jump right into a practice problem. We're going to do 2 practice problems. Please make sure when you try to do this on your own, you are staying organized and setting it up exactly how I am. You probably will get confused if you don't organize your space. So let's start by just reading the problem. So example 1. The element indium has 2 common isotopes. Indium-113, which actually has a mass of 112.90406. You want to use that number. It says U next to it. That just means units. So that's one isotope. The next isotope is indium-115. You're again going to want to use this number. It's just a rounded number for a way to express the mass. This is asking if the average atomic mass is 114.818 units. So this is our average. This is when I add up all the isotopes. This is the number I'm going to get. This is the average mass of all of them combined. But what is the percent of each of these isotopes in nature? That's asking for the percent isotopic abundance. So what I want you to do is set up a chart. You're going to have a chart with 3 columns and I guess 2 rows because we only have 2 isotopes. So indium-113, we're going to start here, and then we have indium-115 here. I'm going to write indium-113. I'm going to write the mass of each of them here. So it's actually 112.90406. And sorry for all the numbers, guys. You need to use all of them. So indium-115 is actually 114.90388. That is the mass. Now, how do I find the percent? I don't know them. I need to determine them. Well, I'm just going to set the percent equal to X. So I know for an isotope, I'm going to have X percent of indium-113. Now I'm going to take the decimal form of 100, which is just 1, and I'm going to subtract X. So I know 100% of all the isotopes minus whatever the percent of this isotope is. So I'm going to set all my percents equal to X and then 100 minus X, depending on how many I have. You guys are only going to work with examples of 2 isotopes. Great, so now that I have my chart, I'm going to set up my equation. I know that after I add up all my percents of each isotope, I'm going to end up with this 114.818. So I know that all the isotopes combined will give me this average. So I'm going to set my equation equal to that number. And then I'm just going to take the first isotope and multiply by the percent. And in this case, it's still just X. So this isotope is 112.90406 times X. And then I'm going to add the next isotope with, what are you doing? With the accompanying percent. Sorry, guys. You can walk. Which is going to be 114.90388. And then that percent is 1 minus X. And now, just distribute that number. So this isn't getting distributed to anything. So I'm going to set that equal to, I distribute this to X. So I have 112.90406 X plus, I'm going to distribute this number to each component in that parentheses. That means I distribute it twice. I distribute it to the 1 and I distribute it to the X. So I have 114.90388 times 1 is just itself. Plus, ooh, I almost got tricked. Minus, plus, times a negative, because I'm distributing it here. Positive and negative equals a negative, so I'm actually subtracting this number. Don't get tricked there. I almost did. So it's going to be minus 114.90388X. Now that you have this big lengthy equation, you are going to combine all of your like terms. I have like x's, and then I have numbers without a variable. I'm going to combine all of them. Let me use a different color for that. So the first thing I'm going to do is combine my x's. So I have both of these x's. You're going to need a calculator for this, and if you don't have a graphing calculator at home, download the app Calculator X. It will help you with all of your calculations. So I'm just going to combine these by taking this and subtracting this number. So 112.90406 minus 114.90388X. That is going to be my X value. So I have negative 1.99982. Don't forget that X. Don't be afraid to get negative numbers. You should get a negative number on each side. And let me use another color for the combination of my non-variable numbers. So I'm going to combine this number with this number, which means I'm going to bring this over here. I'm actually using subtraction. This minus this. Let's plug that in. 114.818 minus this number, 114.90388, is going to give me this number. And guys, use all of them. Don't worry about sig figs and stuff. It's not applicable to these calculations. Just write down every number you get so that you are most accurate. So negative 0.08588. Now I'm interested in finding X. Again, X is going to tell me my percent. So in order to solve for X, I'm just going to divide this over this will give me X. So X is going to equal this number divided by, and I'm going to use parentheses because parentheses are my friend, 9982. And I get X equal to, and then just go to that second decimal place, round up. I'm not going to round up here if you have to. Again, sorry guys, let me rephrase. Round up if you have to, except I'm not going to round up here because I got 0.042. It's just going to round up to 0.04. And then if I wanted to make that a percent, I'm just going to move the decimal place, and X equals 4%. So I like to do it from here. You could keep that 0.04 and then subtract the 1 minus 0.04. I like to change everything to percents. I know X is 4%. If the percent abundance of this indium equals 4%, that means this percent abundance is going to be 100 minus this 4%. So this one is going to be more common in nature with about 96% abundance. And sometimes you'll round differently depending on the teacher. I don't want you to go into a bunch of lengthy decimal points. I'm happy with 4% and 96%. Again, you could plug directly into these equations, but if you just solve for this, it's a lot easier to just subtract from 100. And if you're thinking conceptually, this makes a lot of sense. If this is the average and this isotope is closest to the average, then yes, you should see it more in nature than one that is further away from the average. So that's why I'm only seeing this about 4% of the time, and I'm seeing this isotope about 96% of the time. I know that was a lot. I need you guys to bear with me. I'm going to do one more example for you, and then I want you to practice too on your own. Please, please, please reach out if you're having trouble. We are trying to determine what is the percent abundance? How likely am I going to see this isotope in nature? So let's jump into example 2. Example 2. The element luteum, I might have said that wrong, sorry guys, has 2 common isotopes. Luteum-175, and then again I'm going to use this number, and luteum-176, again using this number in my calculation. If the average atomic mass, meaning this is the average of all the isotopes combined, is 174.967. Calculate its percent isotopic abundance. All right, how do I start? I'm going to write that chart. So I know I have 2 isotopes, 175, and I have 176. I know the masses for each of them, 174.94077, and then 175.94268. I don't know the percents. That's what I'm interested in finding. So I just need to set them equal to X. And let me zoom in so you guys can just focus on this problem and not the previous one. That didn't work out as I planned. All right, well, that's as good as it's gonna get. Sorry guys. So X, and then again, I'm gonna use the decimal form so that I can make the correct calculations. This one I'm gonna set equal to 100, or 1 decimal form of 100, minus X, which is that percent that I'm gonna find in nature. Great, let's set up our equation now that we have everything organized. This is my average atomic mass, 174.967. I'm gonna set everything equal to it because when I'm taking average, I am adding everything up and then dividing by how many I have. So I have 174.967 is going to be the average. Then I have this first isotope that I'm going to write in the mass number for, times some kind of percent, so times X, plus my next isotope, 175.94268, times that 100 minus X. Now, just distribute each of those values. You're going to have 174.967 equals 174.94077X, plus the first distribution, 175.94268, times 1. Again, remember to distribute it to that X as well. Positive times a negative gives you a negative, so you're going to have a negative 175.94268X. Combine your like terms. Let me use the other color. So I'm going to combine my X's here. And I'm going to clear everything out on my calculator so you guys can see. I'm going to take 174.94077, subtract 175.94268. So now I'm going to have all my X's on the right side of my equation. equals negative 1.00191x equal, and then I'm going to combine the 2 without that x variable. So I'm going to take this number and I'm going to subtract this number for it because I'm combining like terms. 174.967 minus that 175.94268. And I get a negative 0.97568. Now I want to solve for x. I know I'm just going to divide to get my x value. So x is going to equal this top number divided by, negative 1.00191. And I get x equals point and then 2 decimals, 97. I'm going to turn that into a percent, 0.97 in percent form. I just moved the decimal place twice. 97% abundance. So this x is going to be 97%. And then to find the other isotopic abundance, I'm just going to subtract 97 from 100 because I know this one's 97% in nature. That means the other one is not so common in nature. 100 minus 97 equals 3%. So this one is only going to be about 3% in nature. And then let's just check the concept. So this is my average, about 175. It makes more sense that this isotope of 175 is more common in nature because it is closest to that average. So I will leave this work up here. You can pause it here if you want to work through it. Take about 15 minutes. Don't take any longer than that to navigate the 2 examples online. Again, I'm always here till 3 o'clock. I have office hours today from 11 to 12. So reach out. We can work through them together. Best of luck, guys.